Hello everyone and a very warm welcome, especially to those of you who've managed to join in live so early in the morning. Welcome as well to those of you watching the recorded version of this video. I am Philipp Neudert. I'm a doctoral student in Science and Technology Studies at RWTH Aachen University. What I'm going to be presenting today is shared work, so I'm speaking not only on my own behalf, but also in the name of Mareike Smolka and Stefan Böschen, with whom I work in the Neurosys cluster. As the title indicates, my talk will focus on the question as to how society and ethics can be integrated in innovation processes. I will present empirical insights and reflections on our own attempt to do so in the Neurosys cluster, a high-tech research consortium in the area of next-generation computing. And what I'm going to do is I will develop and argue for the notion of transformative innovation ecosystems as a reaction to our findings. Let me begin with a quick remark on the notion of global justice, the overarching topic of this conference and how it relates to our own research, which is situated in the research tradition of responsible innovation. The debate on social justice revolves around questions such as what is morally owned to whom, by whom on the global level. So how should we interact in the global arena? What is the relevance of nations and national borders? What are the principles, the norms, the institutions required to enable and structure these interactions? And computing is a technological domain in which such questions of global justice and injustice are particularly pressing and good to and easy to observe. For example, you have the global ecological impact of computing. You have social injustices in global hardware value chains. If you think of rare earth materials, rare minerals, there are also issues connected to the application areas. You have risks of discrimination, privacy inflictions, and surveillance posed by AI, an important application area. And there can also be more broadly adverse and distributive effects of that kind of innovation on society, which can result in societal resistance. So our work is situated in a project that tries to address some of these matters, and that is why we work with responsible innovation and responsible research and innovation. And we ask, how can science, technology, and innovation be aligned with ethics, societal expectations, and notions of justice as far as they are and can be known? So we presuppose that that notions of justice already exist and can be evaluated and developed interactively among different actors groups. This slide gives you an overview on the project. Neurosys is a multidisciplinary research and innovation cluster. It focuses on so-called neuromorphic computing technology, a technology which promises to improve the energy efficiency and performance particularly of artificial intelligence and mobile applications, for example, for electric vehicles. For this purpose, scientists, industry actors, and regional stakeholders collaborate to develop and commercialize this brain-inspired computing hardware and corresponding software. So it's not a traditional academia industry project. And to integrate ethics and societal considerations, as I said previously in the development of this novel computing technology, they took us on board, a team of social scientists and ethicists. The project duration, the expected project duration is 3 times 3 years, depending on the positive re-evaluation by the BMBF, by the German Ministry of Research and Education, which means that we may have some time for our interventions to take full effect. But how can we meaningfully engage and intervene in a collaboration that is as large and as diverse as Neurosys? What we've learned is that established methodologies in responsible innovation, many established methodologies, don't seem perfectly suitable because these many approaches typically target individual actors or individual actors groups, or focus on single on-off events where you bring all the stakeholders together and afterwards everyone goes back to their usual routine. So this can result in a neglection of systemic complexities, such as the interdependence between project, bounded environment, and the broader socio-technical environment, or between design choices, for example, for certain materials and questions of global justice. So as a reaction to limitations of this kind, methodological challenges, there are calls for a more systemic approach. Some authors even observe a systemic turn in responsible innovation. And therefore, researchers introduced, among others, the concept of innovation ecosystems to our eye. My colleagues Mareike Smolka and Stefan Böschen, building on this previous work, have developed the notion of responsible innovation ecosystem governance, which they conceptualize as a system-level capacity of diverse actors to reflect on socio-ethical horizons and different streams of the ecosystem. The underlying assumption here is that through the right intervention, ecosystems at large can be made responsible. But what is an innovation ecosystem in the first place? The concept has gained prominence in technology management and innovation studies in particular to understand and explain and to steer innovation. The most prominent example today is the Silicon Valley as a place in which there are particularly beneficial conditions which allow innovation to flourish. But how should we define an innovation ecosystem? There are two influential streams within the literature. Ecosystems can be conceptualized either along the lines of affiliation or of structure. In the first approach, ecosystems are conceptualized as a web of relations between a central firm, such as Apple or Amazon, and other, often smaller actors. So you have this central firm and affiliated other actors, which are in interdependent and symbiotic relationships. And in a latter approach, ecosystem as structure approach, ecosystems are defined as an alignment structure which is required for a value proposition, a shared ecosystem-specific value proposition to materialize. So the focus is not on actors, but on the structure that aligns, or you could also say streamlines actors. And the result is called internal alignment in the name of this value proposition. And two concepts are relevant in the latter approach. First, the value proposition, which is essentially the promise that the ecosystem makes to outside actors. In ecosystems, these are usually complex, meaning that they combine complementary products and services. For example, Tesla promises sustainable but also fast and luxurious individual mobility. And this proposition is complex in the sense that you have a product, the vehicle itself, combined with a range of services, for example, the charging infrastructure or ongoing software updates. And the second concept that is relevant in the latter approach is the ecosystem model, which is basically the answer to the question how the ecosystem creates and delivers value and how that value is appropriated by the actors within the ecosystem. This can, but is not necessarily limited to money earned in markets. This is often assumed, and yes, often the case, but not necessarily so. And as the main strategic challenge in this approach was often seen to align the value proposition and the ecosystem model. But there is another problem on top of the challenge of creating internal alignment. This other problem is related to the socio-technical environment, so competitors, the regulatory environment, customer preference, etc. For instance, there are actors who simply don't want to see socio-technical change because they have invested in the current socio-technical regime and benefit from it. So internal alignment can be insufficient for the ecosystem to succeed. In response to these findings, Bob Walraven and colleagues have developed a framework for what they call path-breaking innovation, that is, innovation that allows to break away from previous path dependencies. For this purpose, they draw on insights from the multi-level perspective, or MLP. In the MLP, socio-technical change happens when macro-political, macroeconomical, or large-scale cultural changes, so-called landscape pressure, open a window of opportunity for niche actors, that is, small networks or even individuals working on novel technologies to succeed. In light of this perspective on socio-technical change, Walraven and colleagues developed their framework. Yet this multi-level perspective on innovation ecosystems is business-oriented, so there is no reflection on the broader aims of actors within the ecosystem within that framework. If we now combine both conceptual lenses, we end up with a simple scheme, a 2x2 matrix. On one axis, you have socio-technical viability. How can the ecosystem survive beyond the niche? Can it successfully challenge or change the regime? And on the vertical axis, you have socio-technical desirability. To what extent is the innovation that the ecosystem seeks to produce desirable in light of grand and global challenges, societal expectations, and calls for global justice? Yes, the scheme is simplified. It is based on a dualistic logic, but it still has merit because as a result, you get these 4 types of ecosystems, which can serve as a heuristic. Ideally, we want to have both, right? An ecosystem that is highly desirable and can help us to break away from unsustainable path dependencies, social and industry specific. But how does this attempt of creating a responsible innovation ecosystem play out in practice? To answer this question, I will now turn to the empirical analysis. On this slide, you can see an overview on what we have done in practice. We began with an analysis of existing visions in neurosys in the cluster. We conducted stakeholder interviews and participant observations. We analyzed documents. Then a second step, we transformed the existing visions in the frame of a scenario workshops into co-created scenarios. That was followed by feedback dialogues on the scenarios, the scenario narratives and written account on the scenarios with workshop participants on the one hand, and on the other hand with selected external advisors. And just now in January, we had a strategy workshop in which we invited again members of the neurosys cluster to reflect on strategies for achieving these scenarios. So the main result of our research, in a sense, are the scenarios themselves, but they are not the focus of this analysis, because this analysis approaches neurosys in terms of the ecosystem literature and transition studies, so the mentioned MLP, to make the empirical data speak in a different way, if you will. So the first message, if you analyze it accordingly, is positive, because there is landscape pressure which calls for change in the socio-technical regime in computing and semiconductors, in AI, and in other application areas. So I have mentioned the challenge of sustainability. On top of that, you have the changing geopolitical situation. So you have tensions between China and Taiwan. We might see major disruptions in global value change, and you have the structural transformation in the Rhenish area, which was caused by the phasing out of lignite mining, and in Europe at large towards future industries in light of the grand challenges of sustainability and also changing demographics. But the exact trajectory of these adaptation processes is yet unclear. And the overarching finding is here that, as for now, different kinds of value, as you can see in the table, are proposed to different actors groups, but these propositions don't pile up to a coherent whole. Instead, the propositions are in a way asynchronous. They have not yet consolidated. And on top of that, there is no ecosystem model available which specifies in what exact way value, in the sense of these propositions, should be generated and distributed. A third finding is that there are internal tensions between these value propositions. We have the open questions of synergies, possible synergies, or trade-offs. And as I've mentioned, the question of the trajectory of these broader transformation processes and whether or not they will support or benefit the ecosystem as a whole. So in a bit more analytic terms, the question is, what can an ecosystem look like that overcomes these asynchronous value proposition and simultaneously achieves socio-technical viability and desirability, to circle back to the 2x2 matrix that I've presented earlier? And our preliminary answer is that you essentially need 2 building blocks. The first building block is a synchronized value proposition. So a value proposition that blends together technical, economic, societal, and ethical elements in a coherent way, and offers value not only to customers and consumers, but also to societal stakeholders, including those demanding global justice, for example, in value chains. This attribute synchronized points to the shared nature of these propositions over different streams of the ecosystem. So while material scientists and local business associations and industry actors face completely different challenges and have different aims in their daily work, they should all contribute to this value proposition. They should be, in this sense, be synchronized. Because otherwise, if that is not happening, either the socio-technical viability or desirability or both are put at risk. And the second building block is a suitable ecosystem model, which describes how value is created and how the financial rewards, market income, public funding, or other sources, or from other sources, are distributed within the ecosystem. So, and again, an exclusive focus on markets may put this socio-technical desirability at risk, and an exclusive focus on ethics puts the ecosystem's viability at risk. So we need both. And for this, and to address this challenge, Walrafe et al.'s framework is helpful but not sufficient. So we need a meaningful way to blend together strategic thinking. How can we protect the niche? How can we achieve path-breaking innovation with socio-ethical and socio-political reflection? How can society in the region benefit from computing research and related economic activity? How can desirable non-technical changes be brought about? How can they be supported or even enabled through innovation activity within the ecosystem? But how can this be done, you may ask? To approach this question, what we're trying to do is to synthesize the framework by Walrafe and colleagues with our own findings and with insights from the RI literature. And on this final slide, you can see preliminary results. To become transformative, an ecosystem needs additional system-level capacities that complement the system-level capacity to reflect. These additional capacities serve the purpose of developing a suitable ecosystem model and a synchronized value proposition for this emerging ecosystem. And reflection allows the actors to articulate what kind of innovation they find desirable in light of perceived challenges and injustice. And these complementary capacities should allow these aspirations to be realized. For example, you need to anticipate the landscape changes that could create windows of opportunity for path-breaking, responsible innovation. That is why you need this capacity for strategic anticipation. You need to have governance mechanisms in place that enable a coordinated and effective reaction to an anticipated change, so you can exploit, in a way, this window of opportunity. And you need to be able to successfully collaborate with critical external actors, such as government or industry actors. And in this sense, a transformative innovation ecosystem may allow actors to reflexively shape transformation processes through technology. For now, we only propose that these capacities should be built, and the next step for follow-up research will be to either find or develop methods that can help us building these capacities. That's that for now from my end. I'm sure you have questions. Now is the time to ask them. Thank you very much for listening.